microscope. This is usually above 10,000. This is usually 5 to 7,000 because this is only you see the surface. So TEM will see the internal structure, SEM only see the surface structure. The next question, microscope resolution. What means a resolution? Which means the ability of a lens to separate two small objectives. They come closer. So we want to separate them. And there is a power for that. It's called the resolution power. And this is we want to talk detail in the lab, which equals by lambda divided by 2NA. And we mentioned in the first lab already, this lambda is a wavelength, is a light wavelength. And this NA is a numerical aperture. If you see the lens right here, you see 100x with OU. You will see the number is 1.25. That's called a numerical aperture. And I always make a joke, this is like a size of the engine, a car engine, or the microscope engine. So most of these light wavelengths is 625 nanometer. And you can do the calculation, the RP is equals 260 nanometer. Z equals 0.26 micrometer. Most of the microbiology, microorganism, the size is about 0.5 micrometer because it is larger than 0.25 to 6 micrometer. Therefore, we could do the observation. If larger than that, we cannot do it. If smaller than that, we cannot do it. So, based on this formula, you could see the wavelength of the light, the shorter wavelength, which means the resolution power, the value is small. The small resolution power value, which means greater resolution capability. Okay, so here is the thing. We want to make sure you understand is the small RP value is usually good because it's smaller than the bacteria size. This means a better, or we say larger, resolution capability. That's the sentence you should understand. Usually have that question for true or false in the lab section. Lots of people will be missing. The number has to be smaller the better. Now I'm going to show you something. This is a resolution in a light in the electron microscope. Can you see the difference? The bottom one is the light microscope. The top one is electron microscope. Can you see the fuzzy there? Very clearly. That's the difference between the resolution power. Okay? Okay, this is a bright field microscope. We will absolutely to do in the lab and do a lot. So you can see the most expensive structure of a bright field microscope is these lenses. Ocular lens, objective lens. Then you have an arm, and then make sure you hold on the microscope is 2 arms because it's very easy to fall off. This may be a couple of $1,000s for the lens, for these 2 lenses. There is a stage. There is a control. Okay, you can move back and forth. And how are you going to move up and down? There is a focus knob. The thick one is coarse focus. The thin one is fine focus. There is a stage. There is a one could be generate adjustment light to passing through the specimen. That's called iris diagram. The name is called iris diagram. That's a control panel which can adjust the light going through the specimen. Okay? And this is, of course, is an electron panel. This is used to control the light intensity. What we will generate? A dark image and a bright background. And for these bright field microscopes, there is a very good terminology which is called a parfocal. We will mention in the lab real quick. Which means the microscope, as long as it's focused, it will be stay focused, it will not missing. Then, since we are talking about microscope, we need to talk about the magnification. We want the magnification to be large. So how to calculate the magnification? Is the multiple results of the ocular lens to the objective lens. The maximum we can get, the lab microscope what we have on your bench is 1,000. Of course, it needs oil immersion because the light will have a refraction impact. When they're going through the air, going through the glass, they will be reflected. And we want to remove the air gap to make sure they are in the whole system. So we put 1 drop of the oil there. The reason is the refraction index of the oil and the glass are the same, which is larger than the refraction index of the air. Okay, these we will do in the lab real quick. So I'm going to end off today, and we will continue to talk about dark field microscope on Thursday and the following stuff. And we will have a lab today to practice light field microscope.